Hello, welcome back to 13.5, the Law of Sines. I'm on page 962 doing problems 10 through 13. If you're watching the videos in order, and I don't know if you are, you might notice that I accidentally, my hand brushed up against my iPad when I was adjusting it and I stopped the video. I had one more problem to do. It was problem number 9. So what I did was I did it off camera, and I'll still take a picture of it so you can see it. So the video is going to be a little shorter than what I intended. All right, in this section, the last section, we're talking about what we call ambiguous cases. We don't know if we have a triangle, and if we did, we don't know whether we have one triangle or two triangles. So we need to first figure out if we have a triangle at all, and then if we do, we need to solve it. All right, so I'm relying heavily on this that I had from earlier. I'll be bringing that in a lot. So I have a triangle. I have angle A, which is 55 degrees. I'm going to start off by trying to sketch that. And again, I'm not measuring anything with a protractor. I got my protractor on here somewhere, but I'm not going to use it. So I know that this side is going to go this way, and I know that this is going to be angle A, which is going to be 55 degrees. Got it. Now, opposite of angle A is going to be side A, which is 6. This side right here is side B, which is going to be 9 meters. Now, I'm going to see if I actually am able to have a triangle. So let's look at what I got here. First of all, angle A is acute. So when it's a right angle, when it's obtuse, I can ignore those. Let's do the easy one here. All I got to do is check if A is bigger than or equal to B. Well, here's A6, here's B9. Nope. So for all three of these, I have to compare my other side, A, which is going to come from here, something like that, and I have to compare it with the height. So remember, the height is B times the sine of angle A. For this one, my height is going to be 9 times the sine of 55. So let's grab my calculator and let's see what we got there. 9 times sine 55. Close your parentheses. This tells me that my height is going to be 7.37. Now I want to compare that to my other A. And I'll go ahead and draw this in. I'll do it in red. So this height right here, perpendicular, is going to be 7.37 if I round it off. My side A here is going to be 6, and it's going to be too short. So if I come back here and I say side A is less than my height, I get no triangle. And this problem is finished. You can't solve a triangle if you don't get a triangle. So that problem is finished. There's nothing, you can't find what the other sides are. Okay, so let's do the next one. Try to be organized here. I'm trying to keep everything on my desk here. Okay, this one's nice. So my measure of angle A is 120 degrees. That's interesting because that's obtuse. So again, if I start by drawing that side out, and then I make my angle 120 degrees, which is obtuse. This side right here, which is B, is going to be 4 meters. My other side is going to be 10 meters. Well, I know it's going to go this direction. Is it going to be long enough that it's going to reach this other side? So let's look. Obtuse, A has to be bigger than B. If A is bigger than B, I get one triangle. 10 is bigger than 4. So if I draw this all the way out, and again, I may not have things measured. It looks like I didn't draw it long enough, but that's okay. This is going to be 10. Looks like I do get one obtuse triangle. So let's solve it. So I got the measure of angle A, and since this is side B, this would be angle B, and of course that's going to leave the other two to be angle C and side C. So I get the measure of angle A, which is 120 degrees. The measure of angle B, I don't know yet. The measure of angle C, I don't know. Side A is 10, which I had up here. Side B is 4, and side C, I don't know yet. Okay, so I'm going to use the law of sines. First, I've got an angle and its opposite side. First, I'm going to find this angle because I've got that side. So this time I'm going to use the law of sines the way it's originally written, because the unknown is going to be the sine of angle B. So the sine of angle B over side B, 4, is going to be the sine of the angle that I have, 120. And keep in mind, sine of obtuse angles are positive, so everything's still going to be positive here, over 10. Now, I really want to point out, unlike the previous video where I was looking for sides, now I'm looking for an angle. This does not give me the angle. It gives me the sine of the angle, so I'm going to have to use the inverse sine function to figure it out. But first, let's do this. So sine of B is going to be 4 times sine of 120, close your parentheses, divided by 10. Okay, now that's good because it's a number less than 1. If I get a number bigger than 1, I'm going to be in trouble. All right? If it's less than 0 and between -1, that'll give me a negative angle, and I don't want a negative angle in a triangle. So this number that I get should be bigger than 0, should be positive, but less than the number 1. And if it's not, try it again. So this is approximately equal to 0.3464. You can see it on the calculator. I'm going to hit second sine, and for my calculator I can dump the previous answer into this calculation. This tells me that the measure of angle B is about equal to 20.3 degrees. So I'll write that right here, 20.3 degrees. Which, if I drew my picture more accurate, it kind of makes sense because, again, you know, here's 4, here's 10. I didn't draw it to scale, obviously. 10 would be way out here further. And that means that that angle here, which would actually stretch it, pull it that way, would actually be way, way sharper, more acute. 20.3 actually kind of makes sense. All right, so now, and again, I'm going to compound my error because I'm using that rounded value. I'm going to take 180, subtract 120, which is 60, by the way, and I'm going to subtract 20.3. My last angle is 39.7. It's probably 39.7 something, 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 but it's okay. Side C over the sine of the angle that I just found, 39.7, is equal to, and again, go back to the ratio that I have, side A over the sine of angle A. And again, I keep pointing out that I'm using the same ratio. I'm not really. I'm using the reciprocal of the same ratio, though, but I'm using the same measurements. So 10 times sine 39.7 divided by sine 120, and that should give me about 7.4. Now, one thing to check is that the largest side is going to be opposite the largest angle. So 10 is the largest side, it's opposite the largest angle. That makes sense. The smallest side should be opposite the smallest angle, which makes sense. And of course, the side in the middle is opposite the angle in the middle, Goldilocks. So that does make sense. Okay, so we got that one. Got another acute angle. Let's see what happens. This time I've got 35 degrees. So here's 35 degrees, angle A. If I draw this out a little bit more, here's side B, which is going to be 9. And now I've got 8. Okay. Going back to what I have here, it's acute, and A is less than B, and B is greater than A. So that means this is not going to work out. If A was bigger than B, I'd be able to get to work. So for this one again, I have to find the height. And keep in mind that the height is going to be this side times the sine of that angle. So 9 times sine 35. Which is going to be about 5.16. So if I draw this, which I guess you don't have to, I just think it's easier to see, this is going to be about 5.16. Now what's my side A? 8. That's beyond 5.16. So if I was going to like lean a ladder against a building, 5.16 meters, that'd be a big ladder. But if my ladder was 8 meters long, then it's going to lean against the building kind of like this. So there's one of my triangles. Why do I say one of my triangles? Since 8 is not bigger than 9, I'm going to have another triangle, and I should try to draw it over here. That's actually going to look like this, where this is 35 degrees again, this is 9, and this is 8. And again, my height on this time is on the outside of the triangle, 5.16. So now I'm going to have to solve both triangles. Measure of angle A, measure of angle B, measure of angle C, angle A, angle B, angle C. What do I know? This is 35, and this is 8, and this is 9. Let's find angle B first. So sine of B over 9 equals sine of A, being 35 degrees, over side A, which is 8. So 9 times sine 35 divided by 8. Double check. It's positive and it's bigger, and it's less than 1. That's good. So I do inverse sine of that answer, and I get 40.18 degrees. We'll call it 40.2. Now I take 180, subtract 35, subtract 40.2, and my angle C is going to be 104.8. That's this angle right here. This is angle C. And even though I didn't draw it right, because my 8's not to scale with my 9, hopefully if I drew it better it'd be a little bit easier. I should probably use like a compass so I can like draw. Okay. But this angle is going to be obtuse, which kind of makes sense because 8 and 9 are really close. So I really should like pull that over more for my picture. My picture's not drawn to scale, to mention that. Okay, so now I'm going to do side C over the sine of angle C, which is 104.8. And I'm going to go back to this ratio, but I'm going to find the reciprocal. 8 over the sine of 35. So 8 times sine 104.8, close your parentheses, divided by sine 35. And it looks like I get 13.48. We'll call it 13.5. Okay, that's one of the triangles. The other triangle looks like this. This angle right here is the supplement of this angle right here, which is angle B. That's because, where's my picture? Let me show you this one right here. This side A on the outside is what I found. Remember that the inverse sine always gives you an acute angle, ignoring the negatives. So it's gonna default to the acute. But you have to outsmart it and realize that if I pull this side over to the other side, then I'm going to find this angle. I have to get this obtuse angle right here, which is that one right there, by knowing that this red triangle is isosceles. And whatever my original angle B was is also going to be this angle inside. So I take 180 minus that. So I get the measure of angle A, that's still 35. A is still 8. The measure of angle B now, hit clear, it's 180, subtract 40.2. So now it's the obtuse supplement, which is 139.8. Side B is still 9. And we still have to find angle C and side C. Angle C is easy. Should have left my calculator over here. Do 180, subtract 35, subtract 139.8. And holy cow, angle C is very, very, very small, which again makes sense because if I had drawn my 8 more accurately, it would probably come down this way because 8's real close to 9, and I'd have a very sharp angle up here. So what do I get? 5.2. And this gives me the same thing as this, except I'm going to use a different angle. So C over sine 5.2 equals 8 over sine 35. 8 times sine 5.2, close your parentheses, divided by sine 35. And that's going to give me about 1.3, which makes sense because it would be very, very small. All right, we're going to wrap this up with one more. I have another acute angle. This time it's 45 degrees. So here's my 45 degrees, angle A. Side B is 6. And side A is 7. Okay, so let's go back to my chart. Acute, so again, we didn't have this, did one of those already, okay? Let's check this one because again, this is the easiest one. Is A bigger than B? Yeah, 7's bigger than 6. If A is bigger than B, I get one triangle. So my 7 is going to come out this way. And the reason why, again, you get one triangle is because this side, this red line that I have here, like in this one, I swung it over to connect it right here. If I swing this over, it's going to be over here. It's going to miss. It's going to be on the other side of point A. It's going to miss that side. So that's why I only get one. All right. So the measure of angle A is 45 degrees. The measure of angle B we're going to figure out. Same thing with the measure of angle C. Side A is 7 and side B is 6. So first let's find angle B. Sine of angle B over 6 equals sine of angle A, 45 degrees, over 7. 6 times sine 45 divided by 7 equals 0.6060, which is good. By the way, well, no, sorry, I don't want to say anything about that. It's bigger, it's positive, so it's bigger than 0, and it's less than 1. That's good. Do inverse sine of that answer, and it looks like my angle B, which is right here actually, this is C, is going to be 37.3 degrees. Now let's find angle C. So I do 180, subtract 45, subtract 37.3, and I get 97.7. And finally, for the last, side C over the sine of angle C equals side A over the sine of angle A. Sine 97.7, close your parentheses, times 7, divided by sine 45, and it looks like I get about 9.8. And of course, I only got one triangle with that. All right, we'll see you in class.